Alright, so this video is a continuation of the previous video where we are looking at the 2024 paper 1 internal exam. So in this video we are revising and going through all the questions in this paper. So in the first part we were able to walk through the first 9 questions, and in this video we are continuing from where we left. So this was question 9, so we proceed with the next question, which is question 10. Question 10a says, given that set E is a set of natural numbers less than 10, set A equals the even numbers in set E, and set B is equals to the prime numbers in set B. Can you list set A complement intersection B? So what we do here is we need to know set A complement and set B first. That is our target. But let's decode these sets here. Let's start with the universal set. So we are told that set E is equal to natural numbers less than 10. What are natural numbers? Well, these are counting numbers starting from 1. So if we write here, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So since it says natural numbers less than 10, then we just go up to 9, because if you put 10, this condition won't be met. They must be less than 10. Then set A is a set of even numbers. So even numbers are numbers where 2 can go in without leaving a remainder. So meaning that set B equals to, we have 2 here, 4, 6, 8. So we pick all the numbers where 2 can go in without leaving a remainder from this universal set there. Then we go to the next set, which is set apologies, this is supposed to be set A. This is supposed to be set A, even numbers, set A. So this is set A. Then set B is the one where we have prime numbers. So what are prime numbers? Prime numbers are numbers whose factors are 1 and itself. So what I'm trying to say is only 1 and itself can go in that number without leaving a remainder, and these numbers must be greater than 1. So here we have 2, 3, 5, 7 as our prime numbers. So these are numbers where only 1 in itself can go in without leaving a remainder, and these numbers are supposed to be greater than 1. Okay, so let's go ahead and work our way through. We need to find A complement intersection B. So we know what B is. B is here, but we don't know A complement. So let's go ahead and find the A complement. So what does A complement means? It means that from the universal set, can you remove everything in A? What are you going to remain with? So if we go ahead, we remove the 2, the 4, the 6, and the 8. What do we remain with? We remain with 1, 3, 5, and 7. So these here give us the A complement set. So once we know our A complement, then we can go ahead and work out our question says list set A complement intersection what? B. So A complement intersection B. What does this mean? A complement intersection B means that what is found in set A complement, that is also found in set B. So you can clearly see that there's this 3 here which is there, there's this 5 here which is there, and there's this 7 which is there. So these are the common elements. Intersection means what is found in set A complement that is also found in set what? B. So our answer is 3, 5, and 7. So this is our answer to this problem. So you can just come here where you're supposed to write your answer and then put your A complement intersection B equals 3, 5, 7. We proceed to the next question. The next question is saying, in the following diagram, PQRSTU is a triangular prism such that PQ equals QR. So these sides, this and that, are equal. So if we have a triangle with equal sides, 2 equal sides, that triangle is called an isosceles triangle. Is that okay? So the question goes on to say, state the number of planes of symmetry of the prism. In simple language, when you're asked to find planes of symmetry, we are simply saying, in how many ways can you cut this shape here? In how many ways can you cut this shape here such that the two parts that are going to be produced after cutting will be exactly the same? In how many ways can you cut this triangular prism here to produce two identical parts? So if you look at this closely, I can cut this thing in the middle here. There. You see that? I can cut it there. What will be up here will be exactly the same as what is going to be up there. So that is our first plane of symmetry. Also, I can still cut this plane in this vein here. In this plane here. You see that? So now, you can clearly see if I cut in between there, what will be this side will be exactly the same as what will be this side. So, is there any other way I can cut this? No. Those are the only two possible ways, because we only have 2 equal sides. So, meaning that the triangle we have here has got only one line of symmetry. So, there's this plane here, the one that goes up to there, in between, you cut like that, and there's one which passes in between. So our solution to this thing here is, we can confidently say that it has 2 planes of symmetry. Yeah, I hope you understand what, I hope you get the idea and you understand what is being talked about here. So if we come here, we can come and write our answer: 2 planes of symmetry. Okay, 2 planes of symmetry. Is that clear? Okay, so we can proceed to the next question if what to do here is clear. So let's go ahead and jump straight into the next question. The next question is question 11. In this question, the question is on earth geometry. This is an earth geometry question, and earth geometry is one of the simplest topics in mathematics, so there's no need really to stress about it. The question says, the diagram shows the positions of town A, B, and C on the Earth's surface. So we have town A here, town B here, and town C there. Question A. What is the time at C? What is the time at C? What is the time at C when the time at A is 11:22? So let's take a look at our diagram. So C is on this latitude, on this longitude here. C is on longitude 45 degrees east. Pay attention to the direction. Then at A, the time is 11:22, and we can clearly see that A is on longitude 75 degrees west. So if you look at these two directions here, our compass, it shows that the other longitude is in the west and the other is in the east. So what we do is to calculate our time, we must first find the sum of the longitudes. So we're going to say the longitude sum is equals to 75 degrees plus 45 degrees. If you add this up, we're going to get 120 what degrees. Now we know that every 15 degrees moved to the east or to the west results into either a loss of 1 hour or a gain of 1 hour. Every 15 degrees to the east, you gain 1 hour, and every 15 degrees to the west, you lose 1 hour. So we know that each 15 degrees results into an hour in terms of time. So let's go ahead and calculate how many 15 degrees are there in 120. So the time difference between the two towns, the time difference is equals to 120 degrees over 15 degrees, and we get how many times does 15 go into 120? It's 8. So the time difference between the towns is 80 hours. Therefore, town C, since it's on the eastern part of A, town C is 8 hours ahead of town what? A, because each 15 degrees there results into 1 hour gain. So since it's on the eastern part, we can confidently conclude that town C here, town C is 8 hours ahead of town what? Town A. So what we do now to know the time at town C, we can come here and say time at C is 11:22 plus 8 hours. There, you see that? So we can add, this is 2291. You see that? So time at C is 19:22 hours. First things first, look at the longitudes that you are given. If they are in different hemispheres, the other one is west, the other one is east, add them. Once you add, the answer that you get, divide it by 15 to get the difference in terms of what? In terms of hours between the two towns. So clearly here our difference in hours is what? 80 hours. So town C being on the east of town A, then it means that town C is 8 hours ahead of town what? A in terms of time. Once you know this difference in hours, you can just come and add it to the time at A, then you have your answer. If the two towns are in the same hemisphere, for example, west-west or east-east, all you have to do is subtract the longitudes, subtract the longitudes. It is going to give you the difference in terms of what? Hours. Is that okay? The next question here is saying a plane is flying from town A to town B. So there's a plane flying from this town going to that town there. Then we are told that calculate its speed if the distance between A and B is 7,200 nautical miles. So we are calculating the distance, the speed of the plane. How fast was this plane moving? How fast was this plane moving? So we can come here and write our formula. Speed is distance over time. So what is our distance? Our distance is 7,200 nautical miles. And what is our time? Our time is 9 hours. So clearly in the question here, we're given 9 hours as our time, and 7,200 nautical miles as our distance. So we can go ahead and divide this by 9 hours. So if you divide there, it's very simple. How many times does 9 go into 72? So 9 here, it's 1. 9 in 72 is what? 8. So meaning that our answer is simply 800, because 8 and the 2 zeros give us 800. The denominator here is 1. Any number divided by 1 is that number itself. So it's 800 nautical miles per hour. So this is how fast the plane was moving. This is how fast the plane was moving. So we can come here in our answer space and we put our answers that we have found there. So here, time at sea will be 1922 hours. Avoid putting those dots there. It's not allowed because it might look as if it's a ratio. Avoid putting the dots in between here. If you can't just leave the space there, you can put a dash under there. Not in between, under. The dash must be somewhere down here, like that. So the best is just to leave space between the hours and the minutes. Then our speed is what? 800 nautical miles per hour. 800 nautical miles per hour. So this is how fast this plane was moving. The next question is asking us to solve the equation. Solve the equation 3 to the power 1 minus 2x plus 4 equals 5. So to solve this equation, we need to do a few things. The first one, we have to move this 4 to the other side. So that's called grouping the like terms. So we're going to have 3 to the power 1 minus 2x is equals to 5 minus 1. So if you simply 5 minus 4, 5 minus 4. So here, once we get our 5 minus 4 there, we have 3 to the power 1 minus 2x is equal to, what is 5 minus 4? That is 1. Now, the next thing we have to do is to write this side of our equal sign, the right side of our equal sign, in the same way as the left side of our equal sign. What I'm trying to say here is since the left side has got a base of 3, we need to write this number here to have a base of 3 to the power something. So there's a rule in indices which says that x to the power 0 is equal to 1, where x can be any number. So any number to the power 0 is equal to 1. So this is a principle that we are going to use here. Remember, this question is it falls under the topic index equations, or equations that involve indices. So you must be familiar with that topic also for you to successfully write your exam. So here we have 3 to the power 1 minus 2x. Then this part here will become 3 to the power 0. We know that 3 to the power 0 is what? 1. So it doesn't change anything at all. It doesn't change anything at all. So since we have the same bases here, I can ignore these bases and just work out my powers. So we have 1 minus 2x is equal to 0. So I pick the powers here and there and equate them. So once I do that, I'll group the like terms. Now I would prefer to just move the negative 2x to the other side because it will make it positive. Then I'm going to have, if I do that, I'll have 1 is equals to the 2x. Once it goes there, it becomes positive. So 0 plus 2x is just 2x. I can go ahead and divide here by 2, here by 2. This cancels that, meaning that my x is half. Is that clear? Yeah, so we can come here on our answer space and confidently write that our value of x is actually half. Our value of x is half. Let's go ahead and check out this next question. The question says, the diagram shows a sector AOB whose area is 231 centimeters squared and radius 14 centimeters. The angle subtended by the subtended at the center is theta. Find the value of theta. Take pi to be 22 over 22 over 7. So in this question we are using pi to be 22 over 7. So if you are given a sector, the area of a sector is simply derived from the area of a circle. If we give you a circle, the area of a circle is found by the formula pi r squared. So since a sector is simply a part of a circle, so the formula we use then is the area equals theta over 360 pi r squared. So from this formula here, we are going to use it to calculate the area of this sector. So the first thing that we are going to do is we are going to write down the formula. So area, since this is a sector, is equals to theta over 360 degrees multiplied by pi r squared. So here now we're going to substitute what we know and work out what is not given. The area is given as 231 centimeters squared. So we're going to use it to put it where there's area. The radius is given as 14 centimeters. We'll replace where there's a radius, we'll put 14 centimeters. And pi is also given to be 22 over 7. So where there's pi, we'll put 22 over 7. So let's go ahead and see what this gives us. So we'll say this is a 231 equals theta over 360 multiplied by, where there's pi I put 22 over 7, where there's a radius I will put my 14, not forgetting to square it. Once this is done, I'll go ahead and simplify what can be simplified. So I'll say 231 equals theta over 360, of course that is degrees, by 22 over 7 multiplied by 14 squared means 14 times 14. So if you punch that in your calculator, oh, by the way, you won't be allowed to use a calculator. So if you work it out, you are going to find 14 by 14 gives us 196. So 14 times 14 gives us 196. So at this stage, you can go ahead and simplify what can be simplified. What I mean is you can cancel out some things. For example, 7 can go into 196 28 times. So you can say 7 here, 1, 7 there, 28. So now what do we have? We have 231 equals theta over 360 multiplied by 22 over 1 times 28 over 1. We can go ahead and also cancel out here, because 2 can go into 22 and 2 can go into 360. So say 2 here, we have 11, and 2 here into 360, we have 180. So I'm cancelling 1 to avoid to avoid making my work looking dirty. So I will just proceed to the next stage here, because there's some cancelling here. We can do 2 into 28 and 2 into 180. So we'll do that at the next stage. So you have 231 equals, so I can say over 1 there, since I have a fraction on the other side. 231 equals theta over 180 times 11 over 1 times 28 over 1. So now I can cancel a number that goes into 28 and 180. Yes, 2 can go into both numbers, but it's not the highest common factor. It's not the highest common factor that can go into those two numbers. I think 4 into 28 goes there 7 times. 4 into 180 goes there 45 times. Yeah. So now we can carry on, simplify this way. What do we get here? So we are going to have 231 on this side over 1, just make it a fraction, multiplied by pi times 11 times 7. 11 times 7 is 77 pi over 45 times 1 times 1 is 45. Now our work is easy at this stage. So we can cross multiply this. So what we're going to have is 1 times 77 theta is 77 theta is equal to 231 times 45. So instead of me multiplying 231 times 45, I would avoid that because there's a very high chance that what I have here can go in one of these two numbers. So you see what I'm talking about. 77 here and 77 there. So this will cancel that. I remain with theta is equal to. Now, if you check these numbers here, you see that 77 can go into 231. So instead of me multiplying 231 times 45, then dividing by 77, that will carry more weight than just saying 77 into 77, 1. 77 into 231, we get a 3 there. So meaning that what we have now is, see, on top we have 3 times 45 over 1. Anything divided by 1 is that thing itself. So our value of theta is actually 3 times 45. 45 plus 45 plus 45, that is 135 degrees. So meaning that this here is our value of what? Theta. So we can come here and then write down our theta to be 135 degrees. Is that okay? Yeah, so that is our value of theta, 135 degrees. We can just zoom that out so that you can see the whole solution on one page. So that is what we have gone through there. So the formula for finding the area of the sector is theta over pi over 360. Sorry, theta over 360 multiplied by pi r squared. So that is the formula that we use to get the area of a sector. So you just fuse in what you are given, then work your way through to find what has not been given. So you work your way through to find what has not been given, just like the way we have done it there. Yeah. The question says, given that fx equals 3x plus 5 and g of x equals x plus 4 over 3, find g inverse of x. So this is a very simple question. The inverse of a function is found in 3 steps. The first step, in a few steps. So we write the first step, we say fx, we're finding gx, not fx. So we write the function that whose inverse we want to find. So you say g of x equals x plus 4 over 3. So the first step that you're going to do is replace this g of x, whatever is there, replace it with y. That is the first step. So we are going to, where there's g of x here, we put y equals x plus 4 over 3. Is that okay? Once you're done with this step, you go to the next step. The next step is to make x the subject of the formula. Making x the subject of the formula means that x should be alone on one side of the equal sign, while the rest of the information should be on the other side of the equal sign. So to do that, since I have a fraction here, I'm going to make this a fraction also by saying over 1. Then there, we cross multiply. Are we together? So what is 1 times x plus 4? We know anything multiplied by 1 is that thing itself. So here, we just have x plus what? 4 equals, what is y times 3? That is 3y. Is that okay? Once we are done cross multiplying, we'll have to carry this to the other side. The positive 4 will go to the other side. Why? Because remember, our goal is to remain with x alone on one side of the equal sign. So now what we are remaining with here is x is equal to 3y. This 4 comes this side, it becomes what? Negative. Are we together? So it's 3y minus what? 4. So this is the second step. Once you are done with the second step, then the only thing you have to do is get this function here, the inverse function, this g inverse of x, because that's what we were finding. Where there's y, you write this. So I'll go ahead and do that so that you can see. So where there's where there's x, that's where you put in. Where there's x, that's why you put this. So you replace x with this. So let me go ahead and put this so that you can see what I'm talking about. So here, where we have x here, we are going to put g inverse of what? X. So here, we write g inverse of x equals 3. Then where there's y here, this y here, wherever you have y on the right side, you replace that with what? X. So here I'll write x minus 4. So simple. First step, replace g of x with y. Second step, make x the subject of the formula, which is actually this stage here. X is alone on one side of the equal sign. Then the last step, where there's x, put the inverse what? Function. If it's g inverse of x, you put it the way I've put like this. Then replace the y with what? X. What you have is called the inverse function. So this function here is the g inverse function. Is that okay? The next question is saying find gf of x. So question B here is asking us to find gf of x. So what this means is that there are two functions here. There's the first function and the second function. Pay attention to that. So what we do is, since this one is the first function, it's outside, it's the first one, and this one is the second function, it's the inside function, we are going to get the second function and put it in the first function. Is that okay? Let me show you what I'm talking about here. So I'll write the first function. G is the first function here. So g of x is x plus 4 over 3. So where there's x in g, I won't write anything for now. I'll just write there like that. Is that okay? So where there's x here, I'm not writing in the g function because g is the first function. It's the outside function of the first function. So where g is, I'm not in the function g, where there is x, I'm not putting what in anything there for now, so that I can explain what we are doing. So you can see that f of x is the second function. Because f of x here is the second function, we're going to get f of x, which is this one here, and put it where there's x in the g function. So that's why it's called g f of x. So we get f of x and put it in the g what function. So where there's x here, that's why I left this space. That's why I didn't write x here. I'm supposed to put the function for f. So here it's 3x plus 5. Is that okay? So this is called composition of functions. This is where a function is put in another what function. So you will be given two functions, the first function and the second function. So you get the second function, replace where there's x with the second function in the first function. I really hope that you understood, or that makes sense. That will make sense to you. So let's go ahead and simplify this now. Well, 3x plus 5 plus 4, there's no, the coefficient there is 1. So this thing just remains the same. So we have 3x on top there, plus 5 plus 4, 9 over 3. So this is our GF over x. Of course, we can simplify this. We can go ahead and simplify this by factorizing a 3 on top there. 3 is common. 3 into 3x, you remain with x, plus 3 into 9, 3 over the 3 which is down there. Once you do that, you'll notice that this 3 will cancel that 3. So meaning that our GF of x is simply x plus 3. Okay. Yeah, that's our GF of x. X plus 3. So here, our answer was G inverse of x is 3x minus 4. Here, we are finding GF of x equals x plus 3. Then the last part here, go back to our question, GF of 4. GF of 4. So C is asking us to find the GF of 4. So to get this, where there's the GF function is here. This is our GF function. So what this means is that in this function here, GF of x, where x is, we put what? 4. So we just get this function here, the GF of x, and say where there's x here, we have x plus 3, x plus 3. This is equals to, where there's x, we put what? 4 plus 3 there, meaning that our GF of 4 is equal to what? What is 4 plus 3? It's a 7. 7. GF of 4 is what? 7. Are we together? So we can come here in the answer space, and then we write GF of 4 equals 7. GF of 4. Okay, so we proceed to the next question. The next question is on approximation and estimation. The next question is on approximation and estimation. The question reads, a container of cooking oil has a mass of 15.4 kg. So the mass for 15.4 kg. Question A. Find the tolerance of the mass of the container. Find the tolerance of the mass of the what? Container. So tolerance is simply found by subtracting the upper limit minus the lower limit. What does that mean? The upper limit is the acceptable error. Are you together? Now, let me explain it in this way. When we talk about the upper limit and lower limit, we are talking about what we call the absolute error. So every time you are measuring something, there's a very high chance that whatever you're measuring, the quantity that you're going to record as the measure won't be precise. It won't be exactly the required amount. So in short, there's always room for what we call an error. So that error is what we call the absolute what error. So we have what we call in this error, we have what we call the upper limit and the lower limit in terms of making an error. There's how far you can go going up, or there's how far you can go going down. So if you are given a number, a whole number, if they give you a whole number is a number without a decimal point. For example, they just gave us 15 here. The absolute error is always 0.5. For a whole number, absolute error is 0.5. For example, 15, the absolute value is 0.5. Then for a number which has one decimal place, a number given to one decimal place, the error, or acceptable error, is 0.05. So if you have one decimal place in a number, for example, the one we have here, acceptable error is 0.05. If your number is given to, let's say, two decimal places means two numbers after the point, then the acceptable error will be 0.005. I hope you get the picture here. So if your number is whole, for example 15, your error will be 0.5. If your number is given to one decimal place, meaning one number after the point, for example what we have here, your error is 0.05. If your number is given to two decimal places, the error accepted is 0.05. I hope this makes sense to you. So this is what we are going to use to work through our answer, and let's do it. Yeah, let's go. So to find our absolute error, let's go ahead and work out our upper limit. So to find our absolute error, we get the actual measurement that we are given. So it's 15.4. Then we're going to say plus or minus this 15.4 here, plus or minus, we subtract the error. So this is one decimal place, so we are going to use 0.05 since our number is given to one decimal place. So we add and subtract 0.05 to the actual measure that we are given. So now here we have our upper limit. From this we are going to say, when we add, we get the upper limit. So we say 15.4 plus 0.05. If you add that, it's going to give us 15.45. that is our upper limit. Then let's go ahead and work out our lower limit. So to get our lower limit, we just do exactly the same thing we've done here. We just get our 15.4 and add the, sorry, this time around, because we want to know the lower limit, we do the subtraction. We subtract 0.05, which gives us what? 15.35 there. So now, since we know our upper limit and our lower limit, we can go ahead and substitute in the formula for tolerance there. So it means that our tolerance is 15.45 minus 15.35. What is 15.45 minus 15.35? You notice that our answer will be 0.10 kg. So here is our tolerance. So I can come here and say tolerance is equals to 0.10 kg. That is our tolerance. So to find the tolerance, all we need is to work our upper limit and work our lower limit. Just bear in mind that if the number or the mass you are given is a whole number, what you're supposed to do is add and subtract 0.5 to that number to get the upper and the lower limit. If the number you're given is to 1 decimal place, add and subtract 0.05 to that number to get the upper and the lower limit. If the number you're given is given to 2 decimal places, add 0.005 and subtract it from that number to get the upper and the lower limit. Then you can use those two, the upper limit and the lower limit, to work out your tolerance. Is that okay? So let's go ahead and check the next question. The next question says write down the relative error of the mass of the container of cooking oil as a fraction in its simplest form. So we are going to work out our relative error. I'm looking for space here. Okay, so because I don't have space, allow me to, let me just squeeze it here. So they want us to do the relative error. So the relative error will be equal to the absolute error over the true value. So if we substitute here, you will find that our absolute error is 0.05 over our true value, which is 15.4. See that? So to work this as a fraction, we'll look at the top number has got more decimal places than the bottom number. So I'll have to multiply this by 100 and this by 100 there. Multiply with the same number so that we Q or remove the decimal point. So 0.05 times 100, it means the point will have to move to the right 2 times. So meaning that we're just going to have a 5 here over 15.4 times 100. The point will move 2 times because there's no number here. We'll put a 0. So we're going to have 1540. Is that okay? So now our 0.05 over 15.4 is 5 over 1540. So I can go ahead here and divide. 5 into 5, 1. 5 into 15, 3. 5 into 5, 1. 5 into 4, it can't, so I put a 0 there. 5 into 5, it can't, and then I have to get the 4 and the 0 together. 5 into 40, I get 8. So meaning that my answer is 1 over 308. 1 over 308. So just multiply. The absolute error is the acceptable error when I talked about it. If your number is to 1 decimal place, your absolute error is 0.05. If it's a whole number, 0.5. If it's to 2 decimal places, it's 0.005. So you go ahead, replace your absolute error on top over the true value is what you are given in the question. I hope this is making sense. So our relative error there is 1 over 308. 1 over 308. Yeah, so let's go ahead, let's proceed to the next question. The next question is question 15, and in this question here, the first part is transformation, then the second part is on is calculus. So for transformation question, it says the diagram in the answer space, this diagram here. So the diagram in the answer space shows triangle ABC with vertices A 2,3, B 4,2, C 4,4. Triangle ABC is mapped onto triangle A1, B1, C1 under a reflection in the line X equals 6. Draw triangle A1, B1, and C1 on the diagram. Okay, let's come here. So a reflection, there must be a mirror. So we are told that the mirror is the line X equals 6. So this is where X is 6. So I'll come here and draw a straight line. Wow, a straight line. Okay, we can do better. Okay, let's draw a straight line. This is where our mirror will be. Okay, so assume this line is passing exactly on the line for 6. So this is our mirror. So they're saying there's another triangle which is a reflection of this one here. There's a triangle which is a reflection. So if the image is here, then you expect the reflection to be on the other side here. This is where you expect to have the reflection. So if 6 is the mirror, for us to find the reflection, we just have to count to find the position of B1, C1, and A1. So for example, for me to find where the image of B1 will be, I count from the mirror line. It's 1, 2 steps, right, in this direction. So to get where B1 is, I'll come here and count 1, 2. So here is where we're going to have our B1. Same with C. On this line here where y is 4, there's 1, 2 steps to get to C. It means the C1 is 1, 2 steps on the other side. So this is where C1 is going to be. How about point A? We go on the mirror line and count how many steps are there from here to A. So it's 1, 2, 3, 4 steps. So here I'll also do the same. I'll count 1, 2, 3, 4 steps. Is that okay? So here, that is where my A1 is going to be. So meaning that the reflection of triangle ABC is actually here. You see that? So this acts as a mirror, then this is the image, and this is the reflection there. Is that okay? Yeah, so this is exactly what the examiner expects you to do. Just plot this point, right? C1, A1, and B1 there. So we proceed. Let's go to the next question. The next question is saying the equation of the curve is y equals x minus 2x squared plus 1 over x to the power 3. Find the dy dx. So this is calculus, and this is a question on differentiation. So the key concept you need to know here is that under differentiation, if you are given y is equals ax to the power n, where a is a coefficient, n is the power, then y prime, which is just the same as saying dy dx, y prime, which is just the same as dy dx, is equals to, I drop this power down here, so I will have n, you see that, then times a to the power, I subtract 1 on the power there. So I drop this power down, multiply it with a, then on the power I subtract 1. That's the rule that we use in differentiation. So if you have an expression ah to the power n, then n drops down and multiplies with the coefficient, then from the power you also subtract 1. Another key thing I need you to notice here is the rules of indices. The rule which says if you have x to the power negative n, then what you get is 1 over x to the power n. Hello? So if you have 1 over x to the power n, it's the same as saying x to the power negative n. And if you have x to the power negative n, it's the same as saying 1 over x to the power what? N. So from these concepts here, this one and that one, we can go ahead and work our equation. So dy dx, which is the same as y prime. If you don't want to write dy dx, you can write it like this. But let's go ahead and write dy dx here is equal to, the first number is x. So if you look at x, the power of x is what? 1 here. You see that? Let me just rearrange this before, let me rearrange this before I find my dy dx to make work easier for some people. So the power of x is 1 there, minus 2x squared, right? Plus, using this rule here, 1 over x to the power n is equals to x to the power negative n. You look at this expression, it looks exactly like it. This part of the expression here, it looks exactly like that one. So I can write this expression in this form. You see that? What does it become? It will become, instead of me having 1 over x to the power 3, I'll have x to the power negative what? Negative 3 there. So that's how the expression would look like if I do write it. So now once this expression has been rewritten, I can go ahead and do my dy dx is equal to, drop the 1 here. I'm going to have 1 times x, which is just x, then subtract 1 from the power, 1 minus 1 there. You see that? Then I drop this 2 here, I'll have negative 2 times 2, then x there to the power 2 minus 1. I'm using this rule here. Drop the power, multiply it with a coefficient, subtract 1 from the power. We go ahead to the next part there. I have a negative 3 as a power there. I drop it. The coefficient here is 1. So negative 3 times 1 is negative what? 3 to the power x. So negative 3 x to the power negative 3. I subtract 1 from that power there. Let's go ahead and simplify this. What do you get? This is x to the power 0. This is negative 4. Then x, 2 minus 1, 1. Then we have a minus what? 3, right? X to the power negative 3 minus 1 is what? Negative 4. If we go ahead and simplify this, what are we going to have? Any number to the power 0 is 1. Anything, any number to anything to the power 0 is 1. So minus, this is just 4x. Power 1 is just the same as not writing the power. Then here we have negative 3. Are we together? Now, x to the power negative 4. If we go back and look at this rule here, x to the power negative n is the same as saying 1 over x to the power what? And so we have to take this negative down. We can't leave our answer with a negative what? Power. So we're going to say negative 3 times 1 over x to the power what? 4. The 4 becomes positive once it goes down there using this rule here. This is a rule of indices. So we can confidently say then our dy dx is 1 minus 4x minus 3 times 1 is 3 over x to the power 4 dx. Is that okay? Yeah, so you can come and write your answer here for question B. You can put your answer here. When we say dy dx, let me use y prime. Dy dx is equal to, we have 1 minus 4x minus 3 over x to the power 4. the x means with respect to x. So if you put the x in front here, saying I was differentiating with respect to x. Is that okay? Yeah, so our video is yeah, I think it's long enough now. We can't make it much longer, because it might end up becoming too long for some people. It might become boring. So this is the second part of the video on this paper. This is the second video on the same paper, 2024 paper 1 internal. So we have done questions 10 go to question 15, and I think the video is long enough. We can pause here. I want you to watch out for the next video, because the paper is not yet done. We have some questions that are coming up ahead. Variation here, we have a second theorem here, we have social, commercial arithmetics, and the vectors here. Is it coordinate geometry? And there are many other questions that are coming up ahead here. And please, can you watch out for the next video? For now, I think this is enough. To those that are preparing for the exam, those that are writing an exam, I can't wish you nothing less than the best. Go there and do the best that you can. But as you are preparing, make sure that you go through this video and the videos that I'm posting. They are going to help you. They are going to help you. I'm 100% sure that there are many things you can pick from these videos that I'm posting, that can be very helpful to you as you prepare for the exam. If you have a question on things that I have done, or anything else in paper 1 or paper 2 that is still giving you a very serious challenge, please just post your question in the comment section, and I will be able to help you. Post the question, and I'll try my level best to come to your aid on whatever question you're going to ask. Otherwise, for now, thank you for watching the video. Take care of yourself. Bye. See you in the next one.